News. The Intel's executive shake-up under Lee Bhutan on new hires, key results and strategic reset. Since Lee Bhutan took over as CEO, Intel has seen a significant change across its executive ranks, including several key hires and departures. According to the CRN, the company's leadership now features a mix of seasoned veterans and new faces, and the following are some major executive moves under Tan's leadership over the past 6 months. New appointment under Lee Bhutan. As Sharon indicated, Intel announced mid-June the hiring of the veteran engineer Jin Dieter, Ali Grussi, and Sailendra decided to advance its AI computing effort. The company said Ali Grussi, a chip designer with 17 years at Apple, would become the vice president of the AI system on chip SoC engineering. Meanwhile, Desai was named the vice president of the AI fabric and networking through his experience leading silicon engineering for mobile SoC project at Google. At the same time, Intel also hired Srinivasan Iyengar, a silicon engineers leader from the Cadence Strategic custom chip design effort. The report noted that Intel has been identifying the focus on custom silicon as hyperscalers as AWS, Microsoft Azure, and Google Cloud increasingly rely on in-house chip designs to meet their specific performance and efficiency needs. In early September, Intel made 2 additional key leadership appointments. Jim Johnson, a 40-year company veteran, was named head of the client computing group, as well Kavlok Kachichian, a 2-year ARM executive, was appointed to lead the data center group. Before joining ARM in 2023, Kachichian spent 3 years at NXP and 12 years at Qualcomm, according to the report. Leadership executives and transitions. Meanwhile, in the early September, Intel announced that Mitchell Johnson, Holthouse, CEO of Intel Product, would step down after nearly 30 years with the company. She had assumed the product leadership role in December, following the Pat Gelsinger reported resignation under board pressure. At the time, the Holthouse and CFO David Jin Jr. were appointed the interim co-CEO, the report notes. Following Holthouse's departure, Intel has seen additional senior-level exits, including Xiaolan Ronak Shanghai, senior fellow and Xeon chief architecture, left the company at the end of September. His department marked as the second exit from the Intel's leadership this year, following the Silas Kotabali, who left the January to help lead Qualcomm's renewed server CPU initiative. In addition, in mid-December, Christopher George, head of Intel's US government business, announced his departure effective October 1st. He had led Intel Government Technology since February last year, stepped down a month after President Trump announced plans for the U.S. government to take nearly a 10% stake in Intel and using previously awarded grant funds, the CNN report states. Intel is also seen to depart from its Ohio 1 project, according to WCC Tech, citing Columbus Business First. Sources said the multiple leaders have left, including Kevin Hogan, a lobbyist in securing government support for the project. The report adds that Hogan, who previously attended President Trump's inauguration with interim co-CEO David Jensen, played a central role in building Intel's collaborative ties with the U.S. administration. Next one is New China Design China giant YMTC reportedly moved into HBM using TSV following CSMT and Huawei. With the HBM turning into a scarce resources in the AI boom and approaching effectively off the limit, China is racing to a development issue supply and major tech firms joining the push. Reuters report that a Yangtze Memory Technological Company, YMTC, the country's leading the NAND maker, is gearing up to enter the DRAM market, targeting advanced versions built for AI processors. According to the Reuters, YMTC is working on advanced packaging technology called throughout silicon via TSV, which enables DRAM stacking to produce HBM chips. The effort underscored the Beijing increases urgency to boost its advanced chip-making capability after Washington tightened export control last December. Restricting China saying access to the HBM, the report adds. So although the move caught some by surprise, Chinese tech giants have been steadily ramping up efforts on HBM. As my driver reported in mid-September, Huawei unveiled a multi-year roadmap for HSN the AI chips with planned releases running through the 2028. The rollout reportedly began with the Ascend 950 PR in Q1 2026, notable for its house-developed HBM. Wuhan could become the YMTC's next DRAM hub. It's interesting to note that the YMTC could face domestic competition from CXMT, which is already working on HBM chips. At Joseon Biz reported in August, Changxun Memory Technology (CMMT) has restarted its large-scale capital investment that were previously paused, moving to extend its production of DDR4, DRAM, and advanced fourth-generation HBM3. The report noted that CXMT plans to set up a new production line at the Hefei Anhui facility and bring in the necessary equipment. Also familiar with the matter too, Reuters that YMTC is considered the dedicated part of a forthcoming Wuhan facility to DRAM production. Corporate things file from Chishasha cited by Reuters revealed that earlier this month, YMTC set up a new company to construct a third fab in the Wuhan with a registered capital of 20.7 billion yuan, $2.9 billion. As WCCF Tech explained, China is grappling with several HBM shortage drivers by the surging demand for AI chips. For now, Beijing has been leaning on stockpiled HBM, which is nearly exhausted, the report suggests. Citing data from the analyst report, Reuters noted that the YMTC and two existing Wuhan fabs are currently focused on the NAND. They had a combined capacity of 160,000 12-inch wafers per month at the end of 2024, with an additional 65,000 wafers to be added to 2025. According to the CSI Global, YMTC parent company, Yangtze Memory Technology Holdings recently held a shareholders meeting to formally establish a joint stock company and elected the first board of directors, marking the completion of its restructuring. As the third domestic producer of the 3D NAND, YMTC is valued at 160 billion yuan, ranking 9th among China's top 10 unicorns in the latest Hurun Global Unicorn Index, according to the report. Next one is the next generation UCIe IP subsystem for advanced package design. With the rapidly increasing the connecting demand driven by the AI, ML, and HPC data center use cases, high throughput die-to-die connectivity is more faster than ever. Cadence has already demonstrated its 32 GB UCIe standard package IP subsystem on TSMC 3 nano and 3P process technology. To bring even greater flexibility to our mutual customers, Cadence announced that it had taped out its IP subsystem for the 32 GB UCIe advanced packaging on the TSMC 3 nano and 3P process technology. Building on 7 years of expertise in die-to-die solution and the success of multiple UCI IP subsystem test chips. This next generation product delivers improved performance and flexibility while maintaining the reliability and precision proven by its predecessors. The 32 GB as a UCI AP solution built its predecessors, the 32 GB UCI ESP as well as the 16 GB UCI ESP and the UCI EAP solution. Key features include high-speed data transfer ranging from 4 Gbps to 32 Gbps. This IP supports all UCI data transfers rate from the 4 Gbps to 32 Gbps, offering the flexibility across the various customer applications. This broad speed support makes the IP ideal for diverse use cases and providing a scalable performance to meet the requirement of both low power systems and high throughput systems. Optimize this design for 32 Gbps speed and wide interoperability. The IP is optimized to operate seamlessly at the UCI specification speed of 32 GB, ensuring the robust interoperability with any UCI solution. This optimization enables the best performance metric and broader interoperability. Universal interoperability for various transmitters and receiver configuration. The UCIe transmitter in the Cadence I support both half-rate and quad-rate UCIe receiver implementation, ensuring the broad compatibility across the various configurations with the ability to generate clocks to 16 GB. This IP provides robust support for data rates up to the 32 GB, ensuring the full interoperability in diverse UCI applications. Self-celebrating capability and the hardware-based bring up with no firmware requirement. A key feature of Cadence UCI solution is that self-calibration functionality and hardware-based bring up, which eliminate the need for firmware intervention during the system initialization. This significantly simplifies the setup process by removing the need for the firmware loading. Add rate loopback for the wafer sort and validation. The IP feature set the rate loopback at 32 Gbps, enabling efficient wafer sort, a key feature for D2D solution and simplifying the package part validation. Additionally, the die-to-die D2D loopback mode ensures comprehensive validation across the entire link, including channel from one die to each partner and back, offering complete test coverage for a highly reliable system. Integrated internal PLA like all previous Cadence UCI IP. This IP includes an internal phase-locked loop PLA that autonomously generates the necessary L clock and the high-speed clock within the IP. The user only needs to be supplied 100 MHz reference clock. With the option to provide a L clock from the SoC, this allows for simplified clock management, streamlined integration, and reduced system complexity. Robust performance under extreme operating conditions. Cadence UCI IP solution feature maintenance mode that perform regular ground runtime recalibration to ensure the uninterrupted operation even under changing the conditions such as multiply voltage and temperature drift ranging from the -40 centigrade to the 125 Celsius degree, covering the full industrial range. Support for vendor-defined messaging over sideband links. The IP supports vendor-defined message over sideband links, fully compliant with the UCI specification. This feature ensures the effective communication and control across the die-to-die interconnect, enhancing system integration. It is included in both the 16 Gbps and 32 Gbps version of our UCI IP solution. Broad protocol support. Cadence 32 UCI IP also offered broad protocol support to enable pre-validated high-performance, low-latency, and low-power subsystem for any application. Cadence's new 32 giga UCI AP/IP subsystem mark a major advance in die-to-die connectivity. It offers high performance and power efficiency and integration, supporting a range of advanced packaging options. This IP builds on the reliability and precision of Cadence's previously proven Gen 2 UCI SP and Gen 1 UCI SP and UCI AP solutions, continuing to support features such as self-calibrating capabilities, hardware-based bring-up, and robust performance under varying conditions. As a contributing member of the UCI consortium, Cadence is helping to shape the future of the chiplet ecosystem and meet the need of the modern high-performance computing, data structures, and AI/ML applications. The Philips is also the Cadence and uniting the innovation. CIC 2025 showcases Cadence One Team culture. What happens when 500 Cadence employees from 22 countries come together to share their best ideas? CIC 2025 had the answer. The Cadence Innovation Conference, CIC, is a vibrant celebration of our collective spirit of innovation. This June, global employees across disciplines came together to share ideas, grow their network, and engage with the senior leaders and peers in meaningful ways at this exciting employee conference. The first annual CIC was launched in 2022 as a forum for teams to network, share information, collaboration, and celebrate innovation. A record-breaking year. This year marked a significant milestone for CIC with nearly 1,000 submissions of paper and poster proposals, more than double the number received in 2022. Employees across Cadence submitted these proposals for a chance to present their work at CIC, and the final program featured 70 paper presentations and 80 poster presentations. All were selected through a rigorous review process led by over 100 volunteers from across Cadence business units and global locations. The conference brought together more than 500 attendees from 22 countries, reinforcing the CIC reputation as a hub for innovation, knowledge sharing, and connection at Cadence. Big ideas and hands-on impact. CIC also welcomed two esteemed keynote speakers, setting the tone for a week inspiration, cutting-edge insight, and cross-functional collaboration. Professional Gianluca Laccarino, PhD, Professor Mechanical Engineering, Stanford University. Samir Mittal, PhD, CVP Micron. The event also features a hands-on volunteer activity supported by the Cadence Giving Foundation. Attendees built interactive circuit booklet for middle school students, bring innovation and inspiration to the next generation. As Paula Mathusius, System Verification Group reflected, while building a single educational kit might seem small individually, together our actions become part of something bigger. This year's conference underscored how innovation and confident Cadence is fueled not just by technical breakthroughs, but by the people behind them. The event created space for recognition, learning, and connection across levels and geographics. Opportunity to innovate. CIC designed for creating space for employees to grow their impact by collaborating across disciplines and connecting with the peers they might not work with that day to day. For some, it was an opportunity to present their work on a global stage. For others, it meant
serving a reviewer, session chair, or poster session judge, and gaining visibility and experience. Attendees also had a chance to ask meaningful questions to presenters and innovators across the company at a casual setting. Recognizing our technical chair, CIC 2025 was made possible thanks to the leadership and the vision of the dedicated technical chair. 다음에 DDEM General Chair, Rama SSG, Krishna and Lars DSG, Miche and Twilio SVG, Xenia CPG and SDA, Dan CST. Best Paper and Post winners, Dragon Excellence in Design Silicon. First place presentation, Hanki DSG. Co-authors, Miao, Rich, Frank, Louis, Guoji, Fei, and Xiangfei. The second place presentation, HMD SSG. Co-authors, Binod, Palguni, Vipul, Hari, and Jitendra. First place poster, Emmanuel SSG. Co-authors, Mark, Jonathan, and Warren. Second place poster, Jianjun CSG. Co-authors, Mudit, Annie, Prabal, Sharad, Gaurav, Ashwath, and Krishna. Track 2, Innovation in Earlier System Validation. First place presentation, Chirayu, CSG. Second place presentation, Nehu, NNB. Co-authors, She, Geoff, David. The first place poster, Xiayan, SDN, SDA. Co-authors, Yang Xin, Jiyue, Huang, Gang, and Jian. And second place poster, Attis, SVG. Co-authors, Niteshi and Glauber. Track 3, AI Algorithms and Perceived Intelligence. First place presentation, Dirk, SDA. Co-authors, Giacomo Lingia, John Junlu, and Xiaoliang. The second place presentation, Christopher, CPG. Co-authors, Laurent, Ron, Chris, and Yu. First place poster, Mark, CPG. Co-authors, Vari, Gopal, Pallavi, Jacob, Kate, and Peng Cheng. Second place poster, Mike CST. Track 4, Routine Disruption, Productivity, Scalability, and Beyond. First place presentation, Laurent, CPG. Co-authors, Olivier and Christopher. Second place presentation, Mylene, SVG. Co-author, Augusto. First place poster, Thomas CPG. Co-author, Himanshu. Second place poster, Niar SSG. Co-author, Tadeg. 2025 BU Award recipients. Each business unit, BU, leads its own selection progress tailored to what innovation and high performance look like in its teams. However, there is a shared goal, recognizing people who go above and beyond, those who collaborate with the intention, solve problems creatively, and take the initiative to drive progress. There's no read Formula 2 checklist. Instead, leaders look for those who consistently raise the bar, whether by mentoring others, pushing boundaries on innovation, or collaborating in ways that unlocked progress. Digital and Sign Up Glue. Ashwath Visionary Awardee, Nishant Champion Awardee, Milos Technical Pathfinder Awardee, Wei Hang Rising Star Awardee, Yan Specialist Awardee, Xiaoliang Special Awardee, Silicon Solution Group, Sam Divisionary Awardee, Gautam Champion Awardee, Anishi Technology Pathfinder Awardee, Wen Tao Specialist Awardee, DDEM Team Lead Pathfinder Awardee, Arun, Rising Star Awardee. System Verification Group, Ruan, Visionary Awardee. Darini, Champion Awardee. Army Technology Pathfinder Awardee. Jacob, Rising Star Awardee. Abhishek, Team Leader, Team Lead Pathfinder Awardee. Kaitlin, a Specialist Awardee. Custom Product Group, Mohit, Champion Awardee. Olivia, Technology Pathfinder Awardee. Team, Rising Star Awardee. Arato, Team Lead Pathfinder Awardee. Jejun, Specialist Awardee. System Design and Analysis. Bing, Visionary Awardee. Robert, Champion Awardee. Gunjan, Rising Star Awardee. Jackie, Qinjen, Chijin, Rising Star Awardee. One Day, Rising Star Awardee. Customer Success Team, Takumi, Champion Awardee. Alim, Team Lead Pathfinder Awardee. Jonathan, Rising Star Awardee. Information Technology, Raul, Champion Awardee. Strategy and New Venture Group, Dave's Team Lead Pathfinder Awardee. A moment to reflect. Award recipients were honored at a CIC in front of peers and senior leadership and celebrated in special award dinner. For many, it was a meaningful moment to pause and reflect on the journey behind the work, made possible with collaboration, persistence, and shared purpose. Congratulations to all CIC 2025 award recipients. Your innovation work is not only helping to shape the future of technology, but also exemplifies the power of our one team culture. CIC is a testament to what's possible when our brightness minds come together to share breakthrough and exchange ideas, inspiring one another all across the boundaries. We are already looking forward to what next year's CIC brings. Okay, thank you for your time. See you next time.